Today we are going to be working with factoring trinomials. So when we factor a trinomial, first we want to fill out the box, the top left and the bottom right. Then we're going to factor the constant. Step 3, we'll combine, we'll see which ones can combine to be the linear term. Step 4, we'll fill outside the box, and step 5, then we'll write in factored form. So let's take a look at our first example. So step 1, I want to fill out my box. Top left, I write x squared, bottom right, my 12. So then I factor my constant, which is 12, and my factors of 12 are 1 and 12, 2 and 6, 3 and 4. So now we want to find which ones will combine together to be our linear term, which is 7x. So right now we know we can use 3x and 4x. So we need to have a positive 3x and a positive 4x, because 3x plus 4x equals 7x. So now we have to fill the outside of the box. So this is x and x, because x times x is x squared. So in order for us to get 3x, we have to multiply x by 3. And for us to get the 4x, we have to multiply our x by 4. So then our last step is to write in factored form. So we have x plus 3 times by the quantity of x plus 4. Alright, so let's look at our next example. Step 1, we'll fill out our box. We have g squared in the top left, 10 in our bottom right. Step 2, we're going to factor our constant, which is 10. So 1 and 10, 2 and 5. Step 3, we have to find which ones combine together to be our linear term. So which ones will combine to be a positive 7. So that's going to be a positive 2g and a positive 5g, because 2g plus 5g is 7. So then fill out the outside. So in order to get g squared, we're taking g times g. To get 2g, we have to multiply our g by 2. And to get our 5g, we have to multiply our g by 5. So then when we factor this, it's g plus 2 times by the quantity of g plus 5. I'm going to save this third one for you to do on your own, because it's similar to these two. So let's look at our next type of problem. So fill out our box. So we have d squared in the top left, 42 in the bottom right. So we're going to factor our constant, which is 42. So we have 1 and 42, 2 and 21, 3 does not go into 42. So then we have, 4 does not, 5 doesn't. And we know that 6 goes into 42, and 6 goes into 42, 7 times. So now we are all done. So then we need our like terms to combine together to be a negative 17. Am I missing one? Hold on. Oh, sorry. 3 and 14. I did miss 3. So to combine together to be a negative 17, we can take 3 and 14. If we have a negative 3d and negative 14d, negative 3d plus a negative 14d combines together to be negative 17d. And then when we multiply two negatives, they still end up to be our positive. So now we have a d and d times d is d squared. So to get to our negative 3d, we have to multiply it by a negative 3. And to get the negative 14d, we have to multiply it by a negative 14. So in factored form, we have the quantity of d minus 3 times by the quantity of d minus 14. Right, let's take a look at our next problem. So let's fill out our box. So we have k squared, and our constant's 25. So let's factor our constant of 25, 1 and 25, and 5 and 5. So they have to combine together to be a negative 10. So if we have a negative 5k and a negative 5k plus a negative 5k combine to be negative 10k. And when we multiply two negatives, they multiply to be positive 25. So we know we have k times k to get k squared. We have to multiply by a negative 5 to get negative 5k. And multiply this one by a negative 5 to get the negative 5k. So when we factor this, we have the quantity of k minus 5 times by the quantity of k minus 5, which we need to simplify down since we're multiplying the same thing twice. We have k minus 5 squared. That's our final answer. So just like the top one, this third one right here is like these last two. So I'm going to leave that one to do on your own. So let's look at our next type of problem. So same process. We have m squared and then negative 27. So let's factor the 27, just ignoring that it's a negative for right now. So we have 1 and 27, 3 and 9, and that is it. So we need to get to a positive 6. So since we're multiplying by and getting a negative 27, that means one needs to be positive and one needs to be negative. So we're looking at our 3 and our 9. So to end up with a positive 6, we need to have a negative 3m and a positive 9m. Negative 3 plus 9m is a positive 6. And then when we multiply negative 3 by 9, we get a negative 27. So we're going to have m times m to get m squared, negative 3 times m to get negative 3m, and 9 times m for 9m. So when we factor, we have the quantity of m minus 3 times by the quantity of m plus 9. So let's look at our next one. We have p squared and negative 18. So we're going to factor 18. So 1 and 18, 2 and 9, and 3 and 6. So this time we want them to combine to be a negative 3p, keeping in mind that negative 18 is our constant, so that means we have to have one positive and one negative. So to get to that negative 3, we're going to use 3 and 6. So that means we have to have a positive 3p and a negative 6p. 3p plus a negative 6p equals negative 3p, and 3 times a negative 6 is a negative 18. So we have p times p for p squared. We have to multiply p by 3 to get 3p. We multiply our other p by negative 6 to get negative 6p. So we're going to factor this, and we're going to have the quantity of p plus 3 times by the quantity of p minus 6. And just like the other two, this third one is similar to the top two, so I'm going to leave that one for you to do on your own.